Hi guys, welcome to Quantum Chemistries. I am Azam Ali Rasool. Today we are going to discuss about the most important topic of organic chemistry, attacking reagents, which are electrophiles and nucleophiles. See, what are electrophiles? The word electrophile consists of two words, electro and phile. And what is mean electro? Electro means electrons. And phile means love or like. Love for something. And what are electrophiles? Electrophiles are electron deficient species. Understood that electrophiles having deficiency of electron, therefore they attract the electrons to compensate their deficiency. And they are the acceptor of electron pairs. Understood? When they are the deficient of electrons, they can accept the electron pairs and they have the incomplete octet. Now first we discuss with the help of BF3, boron trifluoride. It has trigonal arrangement. Boron electronic configuration is, atomic number is 5, 2 and 3. It has 3 outermost electrons, 1, 2 and 3, and it shares with 3 fluorine atoms and no 2, 4, 6. Boron has 6 electrons and it has incomplete octet. To complete its octet, boron takes the other 2 electrons from ammonia, NH3. As we know that ammonia has 5 outermost electrons, and these 5 outermost electrons, out of 5, 3 shares with 3 hydrogen atoms and 2 electrons are present as a lone pair, and this lone pair of electrons is donated by ammonia, and boron accepts these lone pair of electrons to complete its octet. First, electron deficient species. Second, accept a pair of electrons from ammonia. Third, incomplete octet. To complete its octet, it takes 2 electrons. And Lewis acids. Remember that electrophiles are the Lewis acids. And what are Lewis acids? Lewis acids are those species which has a deficiency of electrons and they accept the electrons. And electrophiles mostly have positive charge, or they are the neutral species. And we take the examples of positive charge, and first of all is proton, H positive ion. H positive has deficiency of electrons and it attracts, due to deficiency of electron, it attracts the electrons, have love for electrons. Similarly, nitronium ion also have deficiency of electron and having partially positive charge on it. And we can explain it by double bond with adjacent to carbon atoms, and a lone pair of electrons is taken away, therefore it has positive charge on it. Similarly, chloronium ion, brominium ion and iodonium ion. Remember that this is not chloride, not bromide, not iodide, but it is chloronium, brominium and iodinium ion. And then the neutral examples of, first off, BF3, boron trifluoride, sulfur trioxide. Sulfur trioxide has trigonal arrangement, double bond with 3 oxygen atoms, and there are 2 electrons. These electrons are shared between adjacent oxygen atoms. As we know that oxygen is a more electronegative element. Due to this, it attracts the electrons strongly towards itself. Therefore, the electron density is maximum in around oxygen atom, and it has partially negative charge. And sulfur has partially positive charge, and it is electrophilic center which attracts electrons towards itself. Similarly, aluminium trichloride, which is a catalyst in Friedrich-Crafts reactions, sulfuric acid is an also example of electrophile, ferrochloride is an also example of electrophile, and stannous chloride. What are nucleophiles? Nucleophiles has all those characteristics which are entirely opposite to electrophiles. The word nucleophile also consists of two words, nucleo and philes. The nucleo means nucleus. And what is nucleus? As we know that the nucleus of an atom has protons plus neutrons. And neutrons are neutrals, means they have no charge, and protons have positive charge. Overall nucleus has positive charge, therefore nucleo means positive charge. And the word phile means love. And what is love? Love for positive charge. Nucleophile means having love for positive charge. And the nucleophiles are electron rich species. And we will explain it with the help of ammonia. Ammonia has 5 electrons. As we have already discussed, its electronic configuration is having atomic number 7, 2 and 5. It has 5 outermost electrons and 3 electrons are shared with 3 hydrogen atoms as a single bond, and the 2 electrons are present as a lone pair. And ammonia is electron rich species, and this electron pair is donated by ammonia. Therefore we called as nucleophile as electron donor species, and they having complete octet. As we know that nitrogen has 5 electrons in its outermost shell, and 3 electrons are shared with 3 hydrogen atoms, and 2 electrons are present as a lone pair, and total electrons are 2, 4, 6 and 8. And nitrogen has in ammonia complete octet of 8 electrons. And the third is Lewis bases. Lewis bases are those species which donate electron easily. As we have already discussed, in electrophiles, nitrogen having a lone pair of electron donated to boron trifluoride. Therefore in this case the boron is a Lewis acid and ammonia is a Lewis base, and they bears partially negative charge or the neutrals. Now we will discuss different examples of nucleophile having negative charge and neutrals. Negative charge, first example is hydroxyline, second one is chloride, iodide, and chloride, as we know that chlorine having atomic number 17, its outermost electronic configuration is 2 and 5, total 7 electrons. Chlorine 2, 4, 6, 7, and 8th one is accepted by some other species, therefore it carry negative charge. Iodine, cyanidine, bromide, fluoride, and this one is carbanium alkyl group having negative charge, and this is phenoxidine, which is formed from phenol, single electrons, and this is take away single electrons, and this is formed from phenols. And the neutral example is phosphorus trichloride, phosphine, ammonia, and these all have lone pair of electrons. And the most common example of nucleophile is water. In water, oxygen has 2 lone pair of electrons, hydrogen, and these are present as 2 lone pair of electrons. This is, as we know that oxygen has 8 atomic number, 2 and 6. There are total 6 electrons in its outermost shells, 2 electrons are shared with 2 hydrogen atoms, and 4 electrons are present as a 2 lone pairs, and these 2 lone pairs of electrons are easily available for donations, and this is electron rich species. Another 2 examples of neutron nucleophiles are the carbon-carbon double bond in alkene and carbon-carbon triple bond in alkynes. Last but not least, electrophiles are donated by E positive charge. Similarly, nucleophiles are donated by Nu with lone pair of electrons. And this is what we have from today's lectures. In next lectures we will meet with a new topic. Till then, goodbye.